Good evening, friends, and I'm CV Sharma. This is CV Sharma back with another video. The video is about the horizontal projection in the horizontal projection of a projectile. Okay, so this is the very simple task. This is the simplest projectile motion as far as I know. And now from a top of a tower, which is of height h, a projectile is thrown with the velocity u horizontally. So this is the condition which is given, and now you have to calculate what are the things we had to do is that you had to calculate how much distance it will go in the x direction, that is called range, and what is the time it takes to hit the ground, that is called time of flight. These are the things which we need to calculate. Range, how much distance it will go in the x direction, and the time of flight. How much distance it will go in the y direction, that is already known. It will cover the entire height h because it falls down. And now how much distance it will cover in the x direction, that is what we have to calculate. And that calculation will be done with the help of the height of the building. Okay, if I can calculate how much distance it will go depending upon the height of the building, and also it depends upon the velocity with which we project it. Velocity with which we project that object. Okay, and now to do this calculation, it is very simple. Now the first part is that when it is thrown horizontally, the velocity in the x direction is u, and the velocity, it is thrown horizontally, no, so the velocity in the y direction is 0. That is well known fact. And now I calculate the displacement in the x direction after a time of t seconds. I can say that the displacement in the x direction is velocity into time, u into t. And the thing is that in the x direction, no acceleration. So there's a situation in x direction horizontally, you don't have acceleration due to gravity. But when you consider the vertical direction, the velocity in the y direction is 0, and the gravity in the y direction is downwards. Okay, that is negative g is what you have. That is acceleration. So you can say that this y is equal to minus half gt square. But this y measurement we are doing downwards, right? So you are doing this y measurement downwards. Since you are doing the measurement downwards, you have to consider this one as negative y. So because the downward direction is negative, so we put negative y here, and now minus y happens to be minus half gt square. So this minus will cancel, and then you get plus. And now we simply substitute t equal to x by u within this. So when you substitute t equal to x by u within this equation, you get y is equal to half g into x by u. T is equal to x by u, will substitute, this is what you get. And y is equal to gx square by 2u square. So this is what the equation of the projectile is. Okay, this is the horizontal projection, and it follows the path of parabola. This is the path of parabola. The path is a parabola. Path is parabola. So this is what we will do initially. So this is y is equal to gx square by 2u square. So this is the equation of the projectile when it is thrown from the top of a building horizontally. So the next part is that how much time it has taken to reach this point. I mean, how much time it has taken to reach this point. Let us say this point is A, and after projection it falls at the point B. How much time it took to reach the point B? How much time it took to reach the ground? This is the calculation which we had to do. So where the thing is that we have how to do this calculation. So you have the equation which is y is equal to half gt square. This is the equation what we have. After a time t is equal to tf, which is called time of flight, y happens to be h, because the displacement we have taken, that is minus y in the y to y direction, that is equal to minus h, y becomes h. So downward calculation, that is always negative. So in that sense, y equal to h, t equal to tf. Let's substitute that. So it becomes h is equal to half g tf square, where tf is the time of flight. So tf happens to be something like this. The tf is equal to 2h by g. Tf square is 2h by g. And tf happens to be square root of 2h by g. Fine. This is what we got. And after this time of flight, this is what the calculation. And now what is the x displacement during the time? That is called the total x displacement. That is called range. Total horizontal displacement. Horizontal displacement. Displacement for the entire journey. For the entire journey. Journey, that is called range. Okay, so we had to find the range of the projectile, and now let us keep this tf here to calculate this range. It is very, very useful. And now we will write this tf as square root of 2h by g. This is what you have. And now we know that x is equal to u times t. So this is the equation first initially we got. But you have what is it? T is equal to tf. You have x is equal to range r. Okay. So let us calculate the range now. Range is the velocity in the x direction multiplied by this is the velocity in x direction, v in x direction, multiplied by time of flight. So this is the idea. Why we can write this equation directly? Because there is no acceleration involved. So we can write this equation directly as there is no acceleration. There is no acceleration. So because this half plus half at square is term getting cancelled out, goes to 0, because in the y direction only you have the acceleration due to gravity. In the x direction you don't have acceleration due to gravity. So u times tf. So tf happens to be 2h by g. So let's substitute that 2h by g. This is what you have. This is how you calculate the range of the projectile in the horizontal direction. How it depends upon the u and the height of projection. This is how the equation is. So these are the very basic projectile motion. These are the very basic points which you need to know when we come across this projectile motion. So this is the range. And now the next one is the oblique projection of the projectile. So how do we find the oblique projection? That will be discussed in the next video. I hope you understand this, and thank you all. Thanks for watching the video. And this is how you can view the calculations. And in the next video, we discuss a little bit about the oblique projection, and then I hope these concepts you already know. And I'm just discussing in a very brief way so that you'll understand for the completion sake. And thank you all. Thanks for watching the video.